Students, now that we have understood the basics of E factor in ESG, let us start with the next topic in E section, which is carbon accounting. Let me start by posing few questions to you. What is the first step in any improvement exercise? I would like you to take a pause and think over. The first step in any improvement process is to identify and understand the baseline or the current situation. For instance, if someone wants to reduce their weight, they must first determine their current weight and understand as to how much they are overweight. Similarly, for a company aiming to reduce its GHG emission, it's essential to first measure and understand its existing emissions. You must have come across financial accounting standards like GAAP, Indian accounting standards, and others. Why do we need them? Why is there a need for an accounting standards? Can you please take a pause and think about it? Imagine if there are no accounting standards. Then every company will report its financial results in its own manner subject to interpretation. This will erode the credibility of financial statements, leading to investor confusion, mistrust, and a higher risk of fraud. Accounting standards ensure five things: consistency over a period of time, comparability between different companies, transparency in reporting, credibility of numbers being reported, and compliance to regulations. What is carbon accounting? Carbon accounting is the process of measuring, recording, and reporting greenhouse gas emissions associated with the organization's operations, products, and services. So, why is it required? As we just saw that for any company which intends to reduce its emission need to first establish the baseline emissions for themselves. This baseline serves as a starting point, allowing the company to set targets for reducing its emission and to track and report its progress over time. Just as financial accounting standards provide credibility and reliability to financial reporting, carbon accounting standards ensure that reported emissions are accurate and trustworthy. These standards also enable comparability between the emissions reported by different companies, ensure consistency in reporting over time, and helps companies comply with regulations. The Greenhouse Gas Protocol or GHG Protocol is an international standard for tracking and reporting greenhouse gas emissions. It was developed by World Resource Institute WRI and World Business Council for Sustainable Development or WBCSD. The GHG Protocol provides a framework for organizations to A. account for their GHG emissions from various sources such as energy consumption, transportation, and supply chains, and B. report their emission in a transparent and consistent manner. The GHG protocol is widely used not only by companies but also by governments, cities, NGOs, and others to measure and report their GHG emissions. GHG protocol has an accepted set of principles in the same way financial accounting does. These five principles are relevance, completeness, consistency, transparency, and accuracy. These principles ensure that reported information represents a faithful, true, and fair account of a company's GHG emissions. Before we proceed further on the GHG protocol, let's understand GHG gases. Greenhouse gases are gases in the Earth's atmosphere that have the ability to trap heat, thereby contributing to the greenhouse effect and global warming. Greenhouse gases act like a blanket. The thicker the blanket, the warmer our planet becomes. What you see on the screen are the major GHG gases. Carbon dioxide, methane, nitrous oxide are the most common GHG gases. Let's understand these gases a little better. Starting with carbon dioxide. CO2 primarily comes from three main sources. First, burning fossil fuels like coal, oil, and natural gas for energy, electricity, heat, and transportation. Second, land use changes like deforestation and urbanization. And thirdly, from industrial processes like steel and cement manufacturing. Once emitted, this gas stays in the atmosphere for centuries. Next gas is methane or CH4. The primary sources of methane include agriculture, landfills, and fossil fuel combustion. Livestock such as cows, sheep, and goats produce methane through a process called enteric fermentation. In their specialized stomachs, microbes break down complex plant material, resulting in the production of a methane as a byproduct, which is then released primarily through belching. Additionally, methane is also generated from the decomposition of organic waste in landfills under anaerobic or low oxygen condition, where the breakdown of organic matter in the absence of oxygen produces methane. Methane has a shorter atmospheric lifetime of about 12 years. However, it is far more effective in heat trapping as compared to the CO2, making it a very potent greenhouse gas. Next, nitrous oxide. The primary sources for nitrous oxide include agriculture, industrial activity, and fossil fuel combustion. Use of synthetic fertilizers and manure management releases nitrous oxide. Industrial activities like production of nitric acid and other chemicals and combustion of fossil fuels releases nitrous oxide. Nitrous oxide remains in the atmosphere for about 114 to 120 years, contributing to long-term global warming. It also affects marginally the ozone layer. We now discuss chlorofluorocarbon or CFCs and hydrofluorocarbons or HFCs. Chlorofluorocarbons or CFC, as they are called, are synthetic compounds containing chlorine, fluorine, and carbon, such as CFC11 or CFC12. Once widely used in refrigeration, aerosols, and foam packaging, CFCs have a long atmospheric lifespan of decades to centuries. They not only cause global warming, but they also deplete the ozone layer. Hence, their production and use has been strictly regulated and phased out under international agreements called Montreal Protocol. Hydrofluorocarbons or HFCs like HFC 134A were introduced as a replacement for CFCs to protect the ozone layer. These gases may not harm the ozone layer, however, they are still potent greenhouse gases contributing significantly to global warming. HFCs are primarily used as refrigerant, air conditioning agents, and foam blowing agents. Their atmospheric lifespan vary but still can be several decades, contributing to long-term climate change. Next, we talk about perfluorocarbons or PFCs. PFCs are synthetic compounds containing only chlorine and fluorine atoms. Known for their exceptional chemical stability, they are employed in various industrial processes including semiconductor manufacturing, aluminum production, and magnesium production. PFCs are very potent greenhouse gases with an extremely long atmospheric lifespan estimated to be thousands of years. Take an example of sulfur hexafluoride or SF6. Due to its exceptional electrical insulating properties and arc quenching capabilities, it is widely used in the electrical power industry as an insulator in high voltage switchgear and circuit breakers. However, SF6 is a very potent greenhouse gas with an extremely long atmospheric lifetime estimated to be thousands of years, making its global warming potential thousands of times greater than that of carbon dioxide. Due to its severe environmental impact, there is an increasing pressure to find out and implement alternatives to SF6 in the electrical industry. Next, we would like to discuss the concept of carbon dioxide equivalent or CO2E, which is a very important concept in carbon accounting. Suppose a company reports its greenhouse gas emission as X1 tons of carbon dioxide, X2 tons of methane, X3 tons of nitrous oxide, X4 tons of CSC, X5 tons of HCFCs. Then it will be very challenging to understand and compare the total impact. To address this, we use a measure called carbon dioxide equivalent. This standardizes the impact of different greenhouse gases by converting their quantities into an equivalent amount of CO2 based on their respective heat trapping abilities. For instance, in the latest IPCC guidelines, methane has a CO2E factor of 28, meaning that 1 ton of methane has the same warming effect as 28 of tons of CO2 over a period of 100 years. Similarly, each greenhouse gas is converted into CO2 equivalent according to the global warming potential for a period of 100 years. For example, sulfur hexafluoride has an extremely high CO2E factor of 25,200, indicating that each molecule of SF6 is 25,200 times more potent at trapping heat than one molecule of CO2 over a period of 100 years. Using CO2 equivalent provides a unified measure that facilitates meaningful comparison of emissions across different companies, supports policy development, and helps in creating effective strategies for reducing greenhouse gas emissions across various sectors and countries. To conclude, in this session, we defined carbon accounting and introduced the GHG protocol as the global standard for carbon measurement and reporting. We examined various greenhouse gases in detail and explored the concept of carbon dioxide equivalent or CO2E to standardize and compare their impact.